Hello, welcome to my channel, The Resting Mind. We have long looked at the night sky and seen the stars as fixed points of light, but beneath that shimmering surface, a silent swarm of invisible giants is moving through the dark. While the word black hole often evokes thoughts of destruction, these wanderers are actually the ancient anchors of our galaxy, moving with a predictable slow-motion grace that poses no threat to our solar system, but offers a map to our origins. We find ourselves tonight drifting through the quiet expanse of the Milky Way, a place of immense scale and profound stillness, where the scent of ozone and the cold touch of starlight define the edges of our understanding. Our story begins not with a bang, but with a realization that the map of our galaxy is far more crowded and far more complex than we ever dared to imagine. The history of astronomy has always been a quest for the visible, a cataloguing of the things that glow, pulse, or burn. We have mapped the spiral arms and the nebulae, the gas clouds, and the planetary systems, believing that what we could see was the sum total of the galactic machinery. However, the true architecture of our home is often found in the spaces between the light. For decades, the movement of stars in our neighborhood seemed to follow the rules of a dance where half the partners were invisible. We felt their gravity. We saw the way they tugged at the fabric of space, but they remained ghosts in the machine. Only recently, through the meticulous eyes of missions like Gaia and the subtle art of gravitational lensing, have we begun to see the silhouettes of the Nomads. There is a certain comfort in the discovery of this subpopulation of black holes. They are not the monsters of science fiction, lurking in wait to consume our sun. They are more like the great blue whales of the deep ocean, moving through trackless currents with a purpose that transcends our brief human timescales. Imagine, if you will, the Milky Way as a vast rotating fluid. In this fluid, the stars are like glowing embers, while these wandering black holes are the heavy, submerged anchors that give the system its hidden momentum. Recent data suggests there may be up to 100 million of these isolated objects in our galaxy alone. Many of them are moving at velocities exceeding 50 kilometers per second, carving silent paths through the interstellar medium like shadows passing over velvet. This isn't a chaotic swarm, though it might appear so at a glance. Instead, it is a secondary circulatory system of the galaxy, a way for mass and energy to be redistributed over billions of years. When we look at the Milky Way, we are looking at a living record of cosmic history, and these wanderers are the sentinels that have survived every era of our galaxy's evolution. They carry the weight of dead suns and the secrets of the early universe, drifting in a state of perpetual, dignified isolation. To find them is to find the missing pieces of a puzzle we didn't even know was incomplete. To understand the nature of this invisible migration, we must shift our perspective from the bright and the loud to the dark and the heavy. We are talking about stellar mass and intermediate mass black holes, objects that range from a few times the mass of our Sun to several thousand times its weight. Unlike the supermassive giant at the center of our galaxy, Sagittarius A star, which sits like a king on a throne, these wanderers are nomads. They were born in the heart of massive stars, forged in the fires of supernovae, and then, through a series of gravitational accidents, they were cast out of their birthplaces to roam the spiral arms. Think of the great migration of the natural world. On Earth, animals travel thousands of miles following ancient rhythms of survival. In the cosmos, these black holes follow the rhythms of gravity and time. As they move, they do not leave a trail of fire, but a trail of warped space. If a wandering black hole passes in front of a distant star, it doesn't just block the light, it bends it. It acts like a cosmic magnifying glass, momentarily brightening the star behind it in a phenomenon known as microlensing. It is through these brief, flickering moments of distorted light that we have finally been able to count the shadows. The realization that the empty space between stars is actually populated by millions of these objects changes everything about how we perceive our galactic home. It removes the sense of void and replaces it with a sense of texture. The space between the stars is not a vacuum of nothingness, but a crowded highway of ancient history. These black holes are the remnants of the very first generations of stars, the giants that lived fast and died young, leaving behind these indestructible cores as their only legacy. They have been traveling since before our sun was even a cloud of gas. As we dwell on this, we feel a sense of awe rather than fear. The sheer scale of the migration is a testament to the longevity of the universe. While empires rise and fall on a small blue planet, these 100 million wanderers continue their slow-motion trek through the spiral arms. They move with a heavy, relentless consistency, indifferent to the passage of days or years. They are the true masters of the long game, the silent partners to the stars, keeping the rhythm of the galactic dance even when no one is watching. The investigation into these isolated black holes has revealed that they are not just scattered randomly. There is a logic to their distribution, a galactic river that guides their path. By studying their velocities, astronomers can trace their trajectories back to the star clusters where they were born. Some were ejected by the violent natal kicks of their parent supernovae, while others were slingshotted away by close encounters with other stars. Each wanderer has a story, a specific moment of origin and a long, lonely journey that has brought it to its current position in the dark. As we settle into the stillness of the night, we can appreciate the grace of this movement. There is a beauty in the invisible, a profound peace in the knowledge that the universe is far more substantial than it appears. The dark is not empty. The dark is full of stories, full of weight, and full of history. We are merely observers on the shore of a vast dark ocean, watching the ripples of the giants as they pass by in the deep. Would you like me to continue with Chapter 2, where we dive into the physics of the Schwarzschild shadow and the tactile nature of warped space-time? To understand the nature of these silent nomads, we must first confront the boundary that defines them, the Schwarzschild shadow. This is not a surface in the way we understand a planet's crust or the roiling plasma of a star, but rather a mathematical inevitability made manifest in the physical world. It is the point of no return, where the escape velocity required to leave exceeds the speed of light itself. In the quiet of the galactic arms, these shadows move like dark glass spheres, invisible to the eye but heavy with the weight of collapsed history. If you were to imagine space as a vast, taut sheet of dark velvet, these wandering black holes are the heavy steel marbles that create deep, elegant wells in the fabric. As they drift, the velvet doesn't tear. It stretches and curves in a slow-motion ripple that follows the nomad's path. We often think of gravity as a sharp, pulling force, but in the vicinity of a wandering intermediate mass black hole, the sensation is one of profound, relentless consistency. It is a tactile experience of space-time itself. Imagine the way a deep ocean current doesn't just pull at your limbs, but surrounds you with a heavy, inescapable pressure that feels almost solid. Near the event horizon, the geometry of the universe is so tightly wound that the very concepts of forward and backward begin to merge. Yet, for all this immense power, the wanderer remains a figure of grace. It does not hunt. It simply exists, an anchor of pure density, moving through a sea of stars, holding the memory of its progenitor star within a pocket of space no larger than a terrestrial city. This shadow is the ultimate transition, a bridge between the world of light we inhabit and a realm of pure, gravitational silence. The mystery of why these specific wanderers remained hidden for so long lies in their isolation. Unlike the supermassive giants that sit at the center of galaxies, surrounded by glowing accretion disks and screaming jets of radiation, the nomads of the swarm are often dark. They travel through the sparsely populated voids between spiral arms, where there is little gas or dust to consume. Without fuel to light them up, they are truly invisible, detectable only when they pass directly in front of a distant star, momentarily warping its light into a brief, shimmering halo. It is a cosmic game of shadows, where we only see the ghost because it momentarily blocks the sun. As we look deeper into this shadow, we begin to see that these are not just remnants of death, but the necessary structural components of the Milky Way's anatomy. Would you like me to continue with Chapter 3, exploring the birth of the nomads and the violent yet beautiful natal kicks that launch them on their multi-billion-year journeys? The birth of these nomads is not a quiet affair, but a moment of sudden, asymmetrical violence that paradoxically results in a lifetime of tranquil drifting. To understand how a black hole becomes a wanderer, we must look at the final moments of the most massive stars in our galaxy. When such a star exhausts its nuclear fuel, the core collapse happens in a heartbeat, yet it is rarely a perfect spherical implosion. Instead, the physics of the explosion, the supernova, often manifests with a slight lean or a structural wobble. As the outer layers are blasted into the void, a torrent of neutrinos is unleashed with such focused intensity that it acts like a rocket engine. This is the natal kick. It is a fundamental law of conservation. As the star's shroud is thrown one way, the newborn singularity is shoved the other. In that singular, explosive instant, the black hole is gifted its momentum, launched out of its stellar nursery at velocities that can reach hundreds of kilometers per second. It is a cosmic slingshot, sending the newborn on a trajectory that will carry it across the spiral arms for the next several billion years of galactic history. These kicked remnants leave behind the glowing nebulae of their birth, escaping the gravitational pull of their sibling stars to enter the vast, lonely stretches of the interstellar medium. They are the orphans of the cosmos, cast out into the dark to find their own path, yet they carry with them the heavy, silent legacy of the giants that came before. Would you like me to proceed to Chapter 4, where we examine the problem of the middle child and the mysterious existence of intermediate mass black holes? The astronomical community has long grappled with a conspicuous silence in the cosmic record, a structural void we often refer to as the problem of the middle child. In the local neighborhood of our galaxy, we have become quite adept at identifying the two extremes of the gravitational spectrum. On one hand, we see the stellar mass black holes, the condensed remnants of dying stars that typically hold about 5 to 10 times the mass of our Sun. On the other hand, we sit in the shadow of the supermassive giants like Sagittarius A star, which anchor the centers of galaxies with the weight of millions or even billions of solar masses. But between these two scales, there has existed a hauntingly empty corridor. For decades, our models predicted the existence of intermediate mass black holes, the missing links weighing between 100 and 100,000 suns. Yet they remain stubbornly elusive, like a ghost species in a fossil record. The swarm we have recently identified changes this narrative entirely, as it appears to be populated by these very wanderers. These are not the small, frantic embers of single stars, nor are they the stationary kings of the galactic center. They are the nomads that fill the gap, existing in a state of perpetual transit. Their discovery suggests that the evolution of a galaxy is not just a story of the very small and the very large, but a continuous, interconnected gradient of shadow. This realization provides the intellectual satisfaction of a puzzle piece finally clicking into place, suggesting that the missing pieces of our universe were never truly gone. They were simply drifting in the quiet spaces where we had not yet learned to look. As we settle into this new understanding, the frantic pace of discovery begins to slow, and we find ourselves observing the mechanics of how these invisible giants make their presence known to us through the subtle bending of reality itself. The detection of such a massive, silent population requires us to look not at the objects themselves, but at the way they influence the light of the stars that lie far beyond them. It is a process of observation that demands a different kind of patience, a willingness to watch for the slightest ripple in the visual fabric of the Milky Way. This brings us to the elegant physics of gravitational lensing, where the invisible becomes a lens for the infinite. Imagine, if you will, the vast distance between Earth and the far edge of the galaxy as a clear, still body of water. When one of these wandering nomads passes through that line of sight, it does not block the light of the stars behind it. Instead, it draws that light inward, curving it around the event horizon, like water flowing around a smooth stone in a stream. From our perspective on Earth, a distant, steady star might suddenly appear to brighten and then dim, or even split into multiple images that form a perfect glowing circle known as an Einstein ring. This is the visual signature of a nomad passing by, a momentary warping of the background stars that reveals the immense hidden weight of the traveler. It feels as though the starlight is being stretched like warm taffy, pulled by a heavy, unseen hand. There is a profound sense of floating behind a massive, invisible magnifying glass, watching the universe distort and reform as these shadows glide through the spiral arms. We are no longer looking at a void, we are looking through a lens, seeing the garden of the galaxy through the refraction of a cosmic raindrop. This movement is not random, nor is it a chaotic scattering of debris. The swarm follows the deep, rhythmic pulses of the galactic river, governed by orbital resonances that keep these nomads in a slow, harmonious dance with the Milky Way's rotation. You are now drifting alongside one of these nomads, moving at a pace that defies the human scale of time. There is no fire here, no light, and no sound, just the immense, silent weight of 1,000 suns packed into a space no larger than a city. You are part of a secondary circulatory system, a silent partner to the stars, gliding through the spiral arms with a consistency that is as reliable as the tides. Moving past the glowing clouds of the nebulae, crossing the dark lanes of interstellar dust, the Nomad remains constant and unwavering. It is a deep, heavy presence that moves with the grace of a deep-sea current, carrying the history of the galaxy in its silent, lightless core. The tension of the search fades away, replaced by the peace of being part of a larger, slow-moving system that has functioned perfectly for billions of years. We are voyagers in a river of gravity, where every motion is deliberate and every path is predestined by the ancient architecture of the cosmos. As the Nomad continues its journey through the thinner reaches of the galaxy, it occasionally encounters the interstellar medium, the ghost-like wisps of hydrogen gas and cosmic dust that permeate the empty space between stars. Even in this near vacuum, the black hole's presence is felt. Through a process known as Bondi-Hoyle-Littleton accretion, the Nomad begins to draw this stray matter toward it. The gas doesn't fall in directly. Instead, it spirals inward, forming a thin, ghostly disk that rotates at incredible speeds. Friction within this disk generates a faint radio frequency hum, a low electronic whisper that serves as a lighthouse in the dark. This is the signature of the friction between the infinite density of the black hole and the infinitesimal lightness of the hydrogen atoms. It is a technical symphony played out in the vacuum, delivered in a rhythmic, monotonic drone that speaks of the fundamental laws of mass and energy. We see the faint purple wisps of gas being drawn into the dark, a visual testament to the relentless pull of the Nomad as it feeds on the memories of the void. This interaction is a reminder that nothing in the universe is truly isolated. Even the most solitary wanderer is constantly in conversation with the space it inhabits, leaving a trail of radio waves that we can trace back to their source. In the presence of such overwhelming gravity, the very nature of time begins to shift. A black hole is not merely a consumer of matter, it is a preserver of time itself. According to the laws of general relativity, as you approach the edge of the Nomad, the passage of time for an outside observer appears to slow down, eventually reaching a state of crystalline stasis at the event horizon. Imagine time not as a ticking clock, but as a thick, viscous liquid that becomes more resistant as you draw closer to the shadow. Every second stretches into an eternity of quiet contemplation. For the Nomad, the entire history of the universe, the birth of new stars, the collision of galaxies, the fading of nebulae, unfolds in what feels like a few fleeting moments, while to us, the Nomad remains a timeless sentinel, unchanged since the dawn of the galaxy. This realization brings a sense of release from the pressures of our daily, linear time. In the vicinity of the swarm, the urgency of the moment fades into the background of a much larger, more enduring reality. We are looking at objects that have stepped outside the flow of the river, holding the past and the future in a single, silent embrace. Sometimes, these ghosts are not found in the open reaches of the spiral arms, but are discovered hiding within the dense, ancient hearts of globular clusters. Imagine 1,000,000 stars crowded together like a hive of fireflies, so tightly packed that their light blends into a single, brilliant glow. At the center of this frantic dance, there is often a heart of pure shadow, an intermediate mass black hole that acts as the conductor of the stellar orchestra. It keeps the rhythm of the dance, its gravity tethering the stars in a complex, multi-layered orbit. The stars do not fall in, they circle. They move softly, staying in their assigned paths, held safe by the very darkness they surround. We sink our perspective into the middle of such a cluster, where the stars seem to orbit nothing. Yet that nothing is the most substantial thing in the room. It is a central shadow, a grounding force that provides structure to the chaos of a million suns. The journey of the swarm is a long one, but it is not without a destination. Over the course of eons, the subtle drag of dynamical friction and the complex gravitational interactions with the galaxy's disk begin to draw these wanderers inward. They are slowly, inevitably migrating toward the galactic center, destined for an eventual merger with the central supermassive black hole, Sagittarius A star. This is not a collision to be feared, and it is not a violent end. Instead, it is a homecoming. After billions of years of wandering through the lonely stretches of the spiral arms, after acting as the silent anchors for clusters and the invisible lenses for distant light, the Nomad returns to the source from which all galactic structure flows. The merger is a slow, rhythmic integration, an adding of one dark legacy to another, increasing the mass and the memory of the galactic heart. It is a process that happens over timescales so vast they dwarf the lifespan of stars, a gentle closing of a circle that began in the fiery aftermath of the first supernovae. In this way, the black hole swarm acts as the ultimate archive of the universe. Every atom of gas, every stray photon, and every fragment of a star that has ever fallen into its embrace is not destroyed, but preserved. The information is held in a vault of gravity that will outlast the stars themselves, protected from the decay of time and the expansion of space. The swarm carries the memory of the galaxy's youth into its old age, resting in the dark, remembering the light, and remaining long after the last star has flickered out. The dark is not empty. It is a library of everything that has ever been. As we look at the stars tonight, we can remember the silent swarm moving between them, and find comfort in the knowledge that even in the deepest dark, there is a path being followed. The universe remains awake, its nomads keeping watch over the long, slow evolution of the cosmos, so that you don't have to. You can let go of the need to watch the horizon, knowing that the silent giants are already there, moving with a predictable, ancient grace through the night. Would you like me to continue with the next chapter, where we explore the dark matter connection and how this swarm might help us solve the greatest mystery in modern astrophysics? To understand the true scale of this discovery, we must first change how we visualize the space between the stars. We often imagine the Milky Way as a collection of bright, lonely islands separated by an empty, sterile vacuum. But the reality is far more crowded and far more fluid. We are beginning to see that our galaxy possesses an invisible migration, a slow-motion transit of massive objects that navigate the spiral arms like great leviathans, moving through the deep, sunless layers of the Pacific. These are the isolated black holes, the silent nomads of the interstellar medium. For decades, these objects were theoretical ghosts, suspected to exist, but impossible to track, because they emit no light of their own. However, recent data from the Gaia mission and sophisticated micro-lensing surveys have pulled back the curtain on this hidden population. The numbers are staggering. We now estimate that there may be as many as 100 million isolated black holes drifting through the Milky Way. They are not tied to any solar system, nor are they anchored to the bright clusters we see in our telescopes. Instead, they move with a startling independence, some traveling at velocities exceeding 50 kilometers per second. This speed suggests they were born in violence, kicked away from their birthplaces by the very supernovae that created them, sent on a journey that will last as long as the galaxy itself. When we observe the movement of these 100 million wanderers, a new picture of our galactic home begins to emerge. This isn't a chaotic, random swarm of debris. If we look closely at the data, we see that these black holes form a secondary circulatory system for the Milky Way. Just as the currents of the deep ocean redistribute heat and nutrients across the globe, these wandering giants redistribute mass and gravitational energy over billions of years. They are the heavy, silent anchors of the spiral arms, moving with a predictable, rhythmic grace that helps maintain the structural integrity of the galactic disk. The realization that the empty space between stars is actually populated by these massive, invisible entities changes the way we feel when we look up at the night sky. The darkness is no longer a void. It is a crowded, active environment. We are surrounded by a silent community of giants, each one a remnant of a star that lived and died long before our sun was even a cloud of dust. They move past us in the dark, not as predators, but as fellow travelers, keeping the long, slow rhythm of the galaxy's heart. We are part of a grand, invisible procession, a migration that spans the entire breadth of time and space, moving quietly through the stars while the rest of the universe sleeps. To understand the nature of this silent swarm, we must look closely at the architecture of the invisible, specifically the region known as the Schwarzschild shadow. This is not a surface in the traditional sense, but a mathematical boundary where the laws of our everyday world simply cease to function. For decades, these wandering black holes remained hidden because they possess no light of their own. And unlike the gluttonous giants at the centers of galaxies, they often travel alone, without a disk of glowing gas to announce their presence. They are defined by their event horizon, a spherical threshold where the escape velocity exactly matches the speed of light. Inside this radius, the paths of all possible futures point inward toward the singularity, a point of infinite density where the very concepts of here and now dissolve into a gravitational knot. Yet as we move away from that center of infinite weight, the experience of the black hole changes from a theoretical abstraction to a tactile reality of the cosmos. If you could reach out and graze the edge of this shadow, you would feel the fabric of space itself pulling at you, not with a jerk, but with a heavy, relentless consistency, like a deep undercurrent in a cold sea. It is a slow, steady dragging of the vacuum, a phenomenon known as frame dragging, where the rotation of the black hole actually twists the geometry of the universe around it. These wanderers are not holes in the sense of being empty. They are the most densely packed objects in existence, acting as gravitational anchors that warp the path of every photon and particle that dares to pass nearby. Their invisibility is their most profound trait, allowing them to glide through the spiral arms of the Milky Way as silent sentinels of mass. To understand how these giants began their long journey through the stars, we must look back to the era of the first light. The genesis of these wandering giants begins in the violent heart of a collapsing star, a process that defines their trajectory for the next 10 billion years. When a star with at least 20 times the mass of our Sun exhausts its nuclear fuel, the outward pressure of fusion ceases, and gravity wins its final, crushing victory. In a fraction of a second, the iron core collapses inward at a quarter of the speed of light. But this collapse is rarely a symmetrical affair. The physics of a supernova is chaotic and turbulent, driven by fluid instabilities that can cause the explosion to lopsidedly favor one direction. As the outer layers are blasted into the interstellar medium, the newborn black hole receives what astrophysicists call a natal kick, a massive conservation of momentum that acts like a cosmic slingshot. This neutrino-driven recoil can launch a singularity out of its birth cluster at velocities exceeding hundreds of kilometers per second, turning a former stellar anchor into a permanent nomad of the dark. These objects do not simply drift, they are exiled, severed from the gravitational nursery of their nebulae and sent on a lonely high-speed transit across the galactic plane. As they travel, they carry with them the extreme density of their past, moving through the spiral arms not as part of the local star-forming traffic, but as independent observers of the galaxy's evolution. This initial momentum ensures they will never settle into a standard orbit, destined instead to weave through the crowded disk as the galaxy's invisible, high-velocity ghosts. The existence of these nomads introduces us to a profound cosmic category, the intermediate mass black hole, or the IMBH. For decades, astronomers observed a curious gap in the celestial census. We could see the stellar mass black holes, the small remnants of single stars, and we could see the supermassive monsters like Sagittarius A star that anchor the centers of galaxies. But the middle ground, the middle children of the cosmos, remained frustratingly elusive. These are the wanderers with masses ranging from a few hundred to several thousand times that of our Sun. Their discovery within this moving swarm is the missing link in our understanding of how gravity builds the universe. They are too large to be formed by a single star and too small to be the center of a galaxy. They likely formed in the dense, crowded centers of ancient star clusters where multiple stars collided and merged. Or perhaps they are the pristine relics of the very first generation of stars that formed after the Big Bang. Identifying these middleweight giants among the swarm suggests that the missing pieces of the galactic puzzle have been hiding in plain sight, drifting through the dark spaces between the stars we've spent centuries mapping. They are the scaffolding upon which the larger structures of the galaxy were built, yet they move with a quiet humility, their presence only betrayed by the way they pull at the fabric of space itself. To understand how these silent giants began their long journey through the stars, we must look back to the era of the first light and the violent, spectacular moments of their creation. While we often imagine a black hole as a stationary drain in the fabric of space, many of the nomads in this newly discovered swarm are actually cosmic refugees, cast out of their birthplaces by the very explosions that gave them life. When a massive star reaches the end of its nuclear fuel, Its core collapses under its own weight, but this collapse is rarely a perfectly symmetrical event. In the final chaotic fraction of a second, the physics of the star becomes incredibly turbulent, and the resulting supernova explosion can happen with a slight bias toward one direction. This asymmetry creates what astrophysicists call a natal kick. As the outer layers of the star are blasted into the void, a staggering burst of neutrinos is emitted, and the conservation of momentum dictates a powerful physical reaction. If the explosion favors one side, the newly formed black hole core is pushed in the opposite direction with immense force. This gravitational slingshot effect can impart velocities of hundreds of thousands of miles per hour, launching the newborn singularity out of its parent nebula and away from its sibling stars. It is a moment of profound, unintended displacement. One moment, the star is a member of a vibrant stellar nursery. The next, it is a black hole, severed from its gravitational roots and sent on a trajectory that will carry it across the spiral arms for the next several billion years of galactic history. These kicked black holes become the true nomads of the Milky Way, wandering far from the galactic plane where they were born. There is a certain quiet solitude in their existence as they traverse the vast empty reaches of the interstellar medium, far from the warmth of any sun. They do not hunt, they simply drift, following the long, curved paths set for them by that initial ancient momentum. They are the orphans of the cosmos, carrying within them the condensed remains of a star that once shone brightly, now transformed into a dark, heavy traveler that will outlast the very galaxy that birthed it. As we map this swarm, we are not just looking at physics. We are looking at the long, slow aftermath of a billion different stellar farewells. The discovery of the wandering swarm brings us face to face with a long-standing frustration in the field of astrophysics, a gap in our knowledge that has felt like a missing rung on a very tall ladder. For decades, we have been comfortable with the two extremes of the black hole family. On one end, we have the stellar mass black holes, the compact remnants of dying stars that weigh perhaps 5 to 20 times the mass of our sun. On the other end, we have the supermassive giants, the gravitational anchors like Sagittarius A star that sit at the heart of galaxies, weighing millions or even billions of solar masses. We see the children and we see the giants, but the middle of the spectrum has remained stubbornly, eerily empty. This is the problem of the middle child, the intermediate mass black hole, or IMBH. These are the objects that should weigh between 100 and 100,000 solar masses. Yet for the longest time, they appeared to be a theoretical impossibility, or, at the very least, a cosmic rarity that eluded our best instruments. The swarm we are now tracking suggests that these missing pieces have been here all along, hiding in the dark reaches between the spiral arms. They represent the connective tissue of galactic evolution, the stage of growth where small black holes merge or consume enough matter to eventually become the seeds of the supermassive monsters we see today. Finding them within this wandering population provides an immense sense of intellectual relief, like finally hearing the missing note in a complex symphony. We are beginning to understand that the galaxy is not just a collection of stars and a single central drain, but a tiered ecosystem where these middle-range nomads play a vital, silent role. They are the transition, the bridge between the small-scale death of a single star and the large-scale governance of an entire galaxy. As we observe them moving through the void, the paradox of their absence begins to dissolve, replaced by the quiet satisfaction of a puzzle finally nearing completion. The middle children have been found, and they are simply taking the long way home. To understand the presence of these hidden giants, we must learn to see not the light they emit, for there is none, but the way they change the light of everything behind them. Imagine a vast, dark pane of ancient glass, moving slowly across a field of distant lanterns. The glass itself is invisible, but as it passes, the lanterns appear to waver, stretching and spiraling into brief luminous rings before returning to their natural state. This is the art of gravitational lensing, the primary tool of the cosmic observer. When a wandering black hole passes between our telescopes and a distant star, its immense gravity acts as a natural magnifying glass, warping the fabric of space-time into a curve. This curvature bends the path of the incoming starlight, momentarily brightening the star and distorting its position in a predictable, rhythmic pulse. It is a subtle signature, a momentary ripple in the visual field of the galaxy that reveals the weight of the unseen. You might visualize this as a single raindrop clinging to a window pane, distorting the garden beyond into a soft, blurred circle. In the same way, these nomads travel through the spiral arms, leaving a trail of optical echoes in their wake. As we watch these Einstein rings form and dissolve, we begin to map the density of the swarm. We aren't just looking at empty space anymore. We are feeling the texture of a massive, invisible lens that covers the entire Milky Way. A layer of gravity that stretches light like taffy, pulling the background universe into new and strange shapes. There is a profound sense of floating behind this magnifying glass, watching the universe bend and flex under the silent influence of the nomads, a process that is as steady and inevitable as the tide. This motion is not erratic, nor is it governed by the chaotic impulses of a younger universe. Instead, the swarm follows the Great Galactic River, a series of orbital resonances that keep these black holes moving in a slow, synchronized harmony with the rotation of the Milky Way itself. You are now drifting alongside one of these nomads, moving at a pace that defies human scales of time. There is no fire here, no violent radiation, and no light to guide the way. There is only the immense, silent weight of 1,000,000 suns packed into a sphere of shadow, no larger than a terrestrial city. You can feel the steady pull of the galactic center, a distant anchor that keeps the entire swarm on a curved, elegant path through the spiral arms. It is a journey of incredible consistency, gliding through the spiral, moving past the nebulae, a silent partner to the stars, existing in a state of perpetual, graceful transit. These black holes are not predators lurking in the dark. They are the quiet cargo of the galaxy, carrying the mass of ancient eras across the void. They move with a constant, unwavering depth, a rhythmic cadence that mirrors the heartbeat of the galaxy itself. Here, in the deep currents of the interstellar medium, the nomad is at peace, a permanent fixture in a system that is far larger and more patient than we often imagine. We are part of this slow-moving system, drifting together through a night that is far more populated and structured than it appears from the surface. To understand the presence of these invisible nomads, we must look not at the black holes themselves, but at the light of the stars that reside far beyond them. Imagine the galaxy as a vast, dark gallery, where the only way to detect a pane of perfectly clear glass is to watch how it distorts the paintings on the far wall. When one of these wandering black holes passes between Earth and a distant star, it acts as a cosmic magnifying glass, a phenomenon known as gravitational lensing. The immense mass of the Nomad reaches out and physically bends the path of the starlight, pulling it into a curve that wraps around the event horizon. For a brief moment, the distant star appears to brighten, its light stretched and smeared into a perfect halo or a shimmering arc, often referred to as an Einstein ring. It is a sight of profound, silent beauty, a momentary ripple in the stillness of the void. If you could reach out and touch this process, it would feel like the slow, elastic stretching of silk, or the way warm taffy yields under a steady pull. There is no friction in this movement, only a heavy, inevitable redirection of energy. You might feel a sense of floating, suspended behind an invisible lens that is miles wide, yet holds the weight of a sun. The sharp edges of the universe soften. The pinpoints of light lose their rigidity, becoming fluid and flowing like water over a smooth stone. This distortion is not chaotic. It is as predictable as the way a single raindrop sitting on a window pane bends the image of the garden behind it. Just as the drop curves the green of the grass and the color of the flowers into a miniature warped world, the black hole curves the history of the galaxy. It creates a brief luminous signature in the dark, a gentle reminder that even what we cannot see has a physical presence that can be felt across the light years. These ripples are the only fingerprints the Nomads leave behind as they glide through the spiral arms, moving with a grace that is both massive and microscopic. As we watch these subtle shifts in the starlight, we begin to realize that the vacuum is not a void, but a textured fabric, capable of being folded and shaped by the silent weight of the swarm. In this realization, the distance between us and the deep dark begins to close, replaced by the steady, rhythmic pulse of the galactic river. The stars that we see as fixed points are merely the foam on the surface of a much deeper, more ancient current. Beneath the vibrant activity of the spiral arms, where gas clouds collapse into new suns and supernovae paint the void with heavy elements, there exists a secondary layer of the Milky Way, a silent, gravitational river. This river is composed of the Nomads we have been tracking, those invisible giants that move not in chaotic zigzags, but in long, sweeping arcs that mirror the rotation of the galaxy itself. They are bound by orbital resonances, subtle mathematical harmonies that ensure they remain part of the collective whole, even as they drift through the most desolate reaches of interstellar space. You are now drifting alongside one of these Nomads. There is no fire here, no light, just the immense, silent weight of 1,000,000 suns packed into a space no larger than a city. To be near such an object is to feel the true scale of the cosmos, not as a place of distance, but as a place of mass and momentum. You are moving at tens of kilometers per second, yet there is no sensation of speed, only a profound sense of stability, gliding through the spiral, moving past the nebulae, a silent partner to the stars, constant, unwavering, deep. As you travel with this shadow, the frantic pace of the living universe seems to fade. The birth and death of stars become like the flickering of fireflies in a distant meadow, while you and the Nomad remain anchored in the slow-moving, heavy water of the galactic tide. Would you like me to continue with Chapter 7, where we explore the faint, ghostly radio hum of the accretion whisper? Even in the near vacuum of the void, these wanderers find traces of hydrogen and dust, drawing them into a thin, ghostly disk that glows with a faint radio frequency hum, a signature that speaks of the friction between the infinite and the infinitesimal. This process, known as Bondi-Hoyle-Littleton accretion, is a slow and methodical gathering of the interstellar medium, where the gravitational influence of the moving black hole creates a wake in the surrounding gas. As the Nomad drifts at its leisurely galactic pace, the gas does not fall directly into the abyss, but is instead captured in a gravitational tug-of-war, swirling into a flattened structure where particles collide and release energy in the form of extremely low-frequency radiation. This is the accretion whisper, a soundless vibration in the electromagnetic spectrum that acts as a beacon for our terrestrial senses. The density of this gas is incredibly low, often consisting of only a few atoms per cubic centimeter. Yet the relentless pull of the singularity is sufficient to condense this sparse material into a state of heightened temperature and pressure. It is a delicate balance of fluid dynamics and general relativity, where the rate of mass accumulation is dictated by the square of the black hole's mass and inversely proportional to the cube of its velocity through the medium. This mathematical harmony ensures that the Nomad remains a quiet observer, consuming just enough to announce its presence to the watchful eyes of science, while maintaining the profound stillness of its long, solitary journey through the spiral arms. The interstellar medium is often perceived as an absolute void, a perfect vacuum of nothingness, yet to a wandering black hole, it is a vast, sparse garden of potential. This thin soup of ionized gas, molecular hydrogen, and microscopic silicates forms the canvas upon which the Nomad leaves its most subtle mark. As the black hole drifts through a relatively dense cloud of this medium, it initiates a process known as Bondi-Hoyle-Littleton accretion, a mechanical interaction where the gravitational influence of the moving singularity creates a wake in the gas, much like the ripple behind a ship. The gas does not simply fall in, it is focused by gravity into a downstream axis, a streamlined flow that eventually curves back toward the event horizon. This creates a ghostly, invisible funnel where the kinetic energy of the particles is converted into thermal energy through a series of internal shocks. Even in the near vacuum of the void, these wanderers find traces of hydrogen and dust, drawing them into a thin, ghostly disk that glows with a faint radio frequency hum, a signature that speaks of the friction between the infinite and the infinitesimal. This accretion is inefficient, lacking the violent brilliance of a quasar, but it produces a steady, low-energy luminosity that hums across the radio spectrum. We listen for this whisper, a specific, non-thermal radiation pattern that distinguishes a black hole from a stray planet or a cooling brown dwarf. The physics here is governed by the stagnation point in the flow, where the gravitational pull finally overcomes the gas's internal pressure, allowing the Nomad to slowly, almost imperceptibly, increase its mass while it sails through the dark. This interaction is the only way the Silent Swarm communicates with the rest of the galaxy, a faint, rhythmic pulse that confirms the dark is not empty, but occupied by ancient, heavy watchers. These whispers are the breadcrumbs of the cosmos, leading us toward a deeper understanding of the invisible architecture that holds the Milky Way together. Each radio wave emitted is a testament to the fact that even the most isolated objects are still fundamentally connected to the fabric of the galactic environment. As we move closer to the heart of the Nomad, the very nature of reality begins to shift in a way that our earthly senses were never designed to perceive. We often think of time as a relentless arrow, a constant and unyielding force that carries us from the cradle to the grave without pause or pity. But in the presence of the swarm, time reveals its true identity as a flexible woven fabric. A black hole is not a consumer of time, it is a preserver of it. Near its edge, the frantic history of the universe slows down, held in a crystalline state of stasis that defies the chaos of the outside world. Imagine time as a liquid, becoming thicker and more viscous as you approach the Nomad, until every second feels like an eternity of quiet contemplation. The ticking of the galactic clock begins to lag, stretching each moment into a long, golden ribbon of existence. In this space, the pressure of the daily grind, the urgency of years, and the weight of deadlines simply dissolve. You are entering a realm where a single heartbeat could last a millennium in the world you left behind. This is the ultimate sanctuary, a place where the universe holds its breath. To be near the Nomad is to be granted a reprieve from the decay of the cosmos. It is a state of profound timelessness, a release of the pressure of daily time, allowing us to simply exist in the heavy, silent grace of the eternal now.